This is going to be a quick run through for the tutorial for week 2, which is Circuit 1 in your Arduino kit. So if you get your kit out and turn to Circuit 1, we're going to start out by getting the components that we need. So looks like we need a breadboard sheet, headers, or we don't really need because that's just for pinning the diagram down, which we're not doing. We need an LED, some wires, and a 560 ohm resistor, which we can tell which one that is by it should have a green, blue, brown series of stripes on it. Okay, so let's start finding those parts. We can also see this is a schematic over here, and their LED image didn't print very well, but basically what we're seeing is here we're going from pin 13 of Arduino through the LED, and they tell us that the longer lead of the LED is what connects to pin 13. Then we'll go from the short end of the LED through our resistor. This squiggly line is the symbol, schematic symbol for a resistor, and then we're going to go to ground. So between that schematic and our circuit sheet, so let's grab, here's my Arduino, here's my circuit sheet. I'm going to need some wires, got those, and it says the 10 millimeter LED, which is the bigger, it's this really big one here. So we'll use that. Let's actually bring the camera down a little bit closer. Okay, so set that off to the side. So we've got the LED. The only other component we need is the resistor, green, blue, brown. So I'm grabbing out all the long lead things. And this one looks like is maybe red, 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 so that's definitely not it. This is brown, black, orange. That's not what we're looking for. These are diodes. That's not what we want. So you can see you've got a whole bunch of these ones that are green, blue, brown. And looking back at our description, green, blue, brown. So I need one of these ones here. So I'm going to just gently pull it out of the tape on each end, roll up the rest of them and put them back for another week when we're going to have a bunch of LEDs out there. And then I'll move this off to the side. I'll grab my wire bundle, I guess. Okay, so between the kind of three-dimensional diagram here and my wiring diagram, which you'll see I'm leaving this off to the side, and I'm going to start by placing my LED. So big LED, you can see one lead is longer than the other, and they say that the longer lead is what they're calling A, and it is going to connect through the breadboard to where this wire is that's going to pin 13. So on mine, I'm going to put the longer lead, I'm going to put that into basically, if you're coming down the rows, I'm going to put it into row 7, column F. And that means the shorter lead is in row 8, column F. Okay. Then I'm supposed to take my 560 ohm resistor and I just gently bend the leads down so they're about even. And now it's supposed to go from the short leg of the LED and it's going to go to ground. And that's represented right here by that resistor that's connected to the short leg, which for me is in row 8. I can't quite see. I guess I can shift it maybe. It looks like they're using rows 9 and 10. So I'm going to shift mine down to match that. So now my long lead is in row 9, short lead's in row 10, and it doesn't really matter. You could pick any of these. I'm just matching exactly what they're doing to kind of help you follow along. Then my resistor goes from the row that the short lead is in, right? Because the short lead is this down part, the lower end of the schematic, connecting to the resistor, from the resistor to ground. So they're showing that by using this outer row with the blue line as ground, and that's common practice. So I'm putting one end of the resistor into any of these holes that are along the blue line, and the other end I'm putting into any of the holes that are in the same row as this lower lead of my LED, so into row 10. Okay, so as we're moving along, I've now made these connections right here between the LED and the resistor, and between the resistor and ground on the board. I haven't connected the actual ground row to anything on the Arduino yet. So again, looking at this diagram, what I've done is, place the LED, place the resistor, and now I need to bring wires to connect it over to the Arduino. So if you look on here, you can see it looks like they're using a brown or purplish wire for going to pin 13. So I don't have anything quite like that color, so I'm just going to pick a white wire. So take a white wire that comes from the long lead of the LED, so that's in row 9 for me, and goes to pin 13 of my Arduino. So if I'm looking along here, you can see they're labeled on the inside of the row of headers and on this side here. So pin 13, you can see, is right next to ground. It may be a little hard to see on this video, but you should be able to see it on yours. Right there is pin 13. So I just bring my white wire and plug it in to pin 13. Okay, so now I've made this connection from the top of the LED to pin 13, and now I need to make some connections for power and for ground. So looking at the schematic, or not the schematic, the wiring diagram, you can see they bring a wire from ground on the Arduino to the row with blue next to it, and a red wire from the 5 volts on the Arduino to the row of red. And just as if you're familiar with electricity, we're actually not using that red wire in this case. You can see it comes from the Arduino and goes to the red power bus, so that we could get 5 volts out of it, but nothing else is connected into that series of receptacles next to the red wire. In future weeks, we definitely will use that, so I assume they're just kind of showing you that to get you in the habit of it. Okay, so I'll take a red wire and go from plus 5 volts. Again, tip it up so I can see the labels. Looks like plus 5 volts is over here on the smaller row, and it's the maybe about 4th pin up there. It's labeled at 5V for 5 volts. So I'm bringing that red wire over and just plugging it into any of these that are along the red wire. Those are all connected electrically. Okay, so I've got the red one plugged in, and now the last wire I have is from ground on the Arduino to the ground bus on the breadboard here. So again, look for ground. There's 2 of them right next to the 5 volts that I connected to, so I'll just use that one and come over and connect to any row in the blue area. So anytime you're connecting to the power supply from the Arduino, that means in either the 5 volt, 3.3 volt, the ground, ground over here, etc. You always want to make real sure what you're doing there. A good way to fry an Arduino is to plug both the red and black wires into the same line, same set of contacts, and then turn it on. That basically creates a direct short, and it'll often burn out the power supply on your Arduino. So make sure you're double check those things before you connect your Arduino to power after you've worked on a circuit. Okay, that's basically it for the hardware this week, a really simple circuit, and now we'll go ahead and write the program. Okay, so we just wired up the hardware on our Arduino, connecting an LED in series from pin 13 through a resistor and back to ground. So that completes the circuit. When power is put out from the Arduino at pin 13, we would expect our LED to turn on. Now we need to write the code to make that happen. So I've opened up just the online version of your experimenter's guide so you can see it next to us as we move along. And you can see that their program starts with a multi-line comment. So I'll start out with my own multi-line comment saying, "This is John's first attempt at blink code." And really, I don't need to use a multi-line comment since I'm just keeping mine shorter, but if I wanted to put in a couple lines there, I could fit them in that way. Okay, so looking down here, we have some declarations about saying what type of variables we're creating and setting a value to it. So we're saying an integer variable called LED pen, and we're setting that equal to 13. So I say int LED pen equals 13, and then put a comment to tell me what that's about. My LED is connected to pin 13 on my Arduino. Okay, and that's my declarations that I need. So oops, I put that in void setup. I need that above there, so cut that out, put that up there, make a little more room. There we go. Okay, now void setup. Inside there, the only command inside void setup, which I can tell what's inside the void setup, is where from this bracket down to this bracket. And you can see those are up here. So I will put in there pin mode. Again, if you've read through the links at the start of the tutorial, you should have an idea what pin mode is. Pin mode. And then I'm saying, what pin am I talking about? In this case, it's pin 13. So I could just put a 13 in here, but I already defined a variable LED pin, so that if in the future I want to change that, I can just change it once up here, and then anywhere else that I use LED pin, it will change that as well. Okay, so I'll put in there LED pin, oops, LED pin, comma, output. So I'm saying that's going to be an output, and then semicolon. Okay, and what that means is sets the pin at number LED pin. So basically saying whatever pin I put into LED pin as an output. Okay. And that's the only command in void setup. Remember, void setup just runs once when your Arduino first powers up. Now we're going to put things down in a loop that will just keep running over and over and over. So our first one looks like it's digital write, oops, capital WRITE, parentheses, and now LED pin again. So we're telling it what pin we want to turn on or off, and we're going to set it to a value of high, meaning we're going to put voltage out on that pin. Okay, turn LED on. Then we're going to wait basically by saying we're delaying by 1,000 of the units, and in this case the units are milliseconds, so that means we're delaying. Oh, I got my semicolon on both those. A common mistake. Oops. Okay. Wait for 1,000 milliseconds. Okay, and then digital write again. Now we're going to turn it back off. Digital write, LED pin to low. So turning the voltage off on that pin. Turn LED off. Okay, and then we delay again for 1,000 milliseconds. Wait for 1,000 milliseconds. Okay, so I will save that. And we'll call this tutorial 2. And verify it. Make sure I didn't make any syntax errors, and I did. Okay, expected, comma, or before void. What did I mess up? Oh, I missed a semicolon up there too. Semicolon, there we go. Okay, try verifying it again. Yep, it verified okay, so now I'm going to download it to my Arduino, or upload it, whichever way you want to say it. And, oh, my Arduino's not plugged in. Hold on a sec. Okay, try uploading it again. Okay, so it's uploading, and you can't see it yet. Let me see if I can pause and turn a camera on here. Okay, so there now I should have a camera going so you can see the Arduino's flashing that LED on for 1 second and off for another second. So let's play around with it just a little bit and change some of those parameters. Let's say instead of being on for a second and off for a second, I want it to be on for half a second and off for a second. So that's going to be one of these two delays, and I said I want it on for half a second, so I'm going to change this to 500 milliseconds, and then we'll leave it off for 1 second. And so let's go ahead and just upload that change in code. You can see while it's uploading, it stops running the program, and now it's back to running it. And you can see it's flashing, it's on for less time. So let's say we wanted to do 2 quick flashes and then a long off period. Starting to think about the tutorial ahead. So let's say we like this 500 millisecond on, and then let's say we want to do a quick flash, a quick pause, another quick flash, and then a long pause. So you can do that, but just kind of keep copying this text that turns things on and off. So I'm going to copy all 4 of these and paste them below. So I said I wanted a quick flash and then a quick pause. So let's say 500 off, then 500 on, and then so it'll turn the LED on, it'll be on for 500. Then it'll turn off for 500. Let's make that a quicker break in between those. Let's say it's off for just a quarter of a second between those 2 flashes. And then it'll be on for half a second again, and then it'll wait a second before it starts that sequence again. So let's download that or upload it and watch what happens. So again, while it's downloading, nothing. There, and you can see there's 2 quick flashes, a long pause, 2 quick flashes, and a long pause. And it's kind of nice to do that copying of chunks so you get your comments and all. But as you're doing this, specifically this week when you're working on the next part of your project, which is going to be your name in Morse code, you're going to want to add some more comments in here that say that these were the first 2 dots or dashes of a letter. You would put a comment in here that says first dash of letter J, second dash of letter J, or whatever the code would be for your name. And that'll make more sense once you get into the project. I just want to show one other thing before I close this video for you, pointing out the flexibility of why rather than just coding in pin 13, we coded in LED pin. So let me show you that. If let's say, I'll show you that it would have worked just the same way. If I put in, copy 13 down here to every place that it says LED pin and upload that to the Arduino, the program will behave exactly the same. You can see it's flashing along just like it was before. The difference is, let's say all of a sudden now I realize I can't wire it to pin 13 because pin 13 has a special function that pin, let's look for another one that we could use. How about we're going to change it to pin 8 instead. And in this case, wouldn't really matter because pin 13 doesn't have a special function, but just trying to demonstrate the idea. So I'm going to unplug this because you never want to make wiring changes while it's plugged in. So I'm unplugging my Arduino, and I'm just moving the wire from pin 13 to pin 8. Now I'm just going to plug it back in and see what happens. So the Arduino started back up. You can see it's running because the little yellow LED is blinking, but my big LED isn't blinking. And that's because the pin that the Arduino is turning on and off is pin 8. So now, if I want to make this work, I can go back and type 8 in here for every pin. But I had to move that 4 times. Let's upload that and see what happens. It's not liking pin 8. You can see it is flashing, but just barely. That probably has to do with the way the setting is for, oh, I know why, sorry. What have I not done when I'm using pin 8? Up here, the pin that was set to be an output is LED pin, so that's pin 13. So I forgot to change that one right there. So, sorry about that. It's a good example though of why the way they did it. So now you can see when I fix that, it's working great again. But that's why they defined a variable, LED pin, to use in all these lines down here. So if I put back in LED pin, everywhere that I'd hard-coded in, pin 8 or pin 13, okay, and let's now change LED pin to be 8, upload that, and it's working again. And watch how quickly now, let's say I want it to be wired to pin 11 instead. I can just change one line of code, unplug it so I'm not making wiring changes, move my wire to pin 11, plug it back in, and upload my sketch with that, just changing the number 11 once in that thing, and now it's functioning the same as if I had changed this to pin 11, this to pin 11, this to pin 11, etc. So that's the purpose of trying to use as many variables in your code rather than hard-coded inputs or outputs when possible. Okay, that's the basic overview of how you would get tutorial working for the Blink LED Circuit 1 in your book. Hope that's helpful.